Sorry. Okay, folks, I forgot to turn on the recorder, so I'll just sort of mention. We're in Chapter 3, Determinants, 3.2, Determinants and Elementary Operations. And what we had done last time was found out the effects of doing an elementary row operation on the determinant of that matrix. Okay, of course we're only talking about square matrices. Those are the only ones you can do determinants on. Okay, and by doing a elementary row operations on a square matrix, you can make it easier, especially with big matrices, to find the determinant. That cofactor expansion, once you get huge matrices, oh my goodness, those are deadly. As we saw at the beginning of this section when we tried to do the 4x4 matrix A, the determinant, last time, we got so bogged down and made some little mistake somewhere, never were coming up close to an answer. Okay? But if you do row reductions, which you're really used to doing, and get that square matrix into a, whoa, here comes Jemanuel. Let me get him in. Okay, so Jemanuel is here. All right. So if only Ricky can make it, we're going to have a full house. That would be fantastic. Okay. Jemanuel, we're in Chapter 3, Determinants, Section 3.2, Determinants and Elementary Operations. And what we've just seen in 3.1, we found out how to take a determinant of a matrix by cofactor expansion, which for, wait, just realized I haven't turned on my light or my ceiling fan. And it was getting really hot in here, so let me get the ceiling fan on to cool things off a little bit. Okay. So we were seeing that, okay, I flipped the page over, sorry, that by doing row operations, especially our favorite, adding a multiple of one row to another row does not change the determinant of a matrix at all. Exchanging two rows negates it, and multiplying or dividing by a non-zero constant also multiplies or divides the determinant by that non-zero constant. Okay, so that's what those are our elementary row operations, the effects of those. So if you have a big matrix like we did at the beginning, a 4x4, much easier to do row reduction. First, we know how to do that, less likely to make so many mistakes, and perhaps come up with the right answer. Once you get it into a diagonal matrix, a triangular matrix, multiply the elements on that diagonal and you've got the determinant. And if all you've done were adding a multiple of one row to another row to get there, then you haven't changed the determinant at all. Now, this table in the book, and I'm going to hold it up so you can see, okay, that table right there really illustrates how much row reductions can simplify your life. So if you have a 3x3 matrix, the cofactor expansion, you have 5 additions and 9 multiplications for a total of 14 operations. If you do row reduction first on a typical matrix with no zeros in it and stuff like that, you have 8 additions and 10 multiplications. That's 18 steps. Cofactor expansion's easier. If you only expand that 3x3 by the first 2 rows, it's even easier. Okay, so 3x3s we know how to do. Now, they don't list a 4x4 here, they go on to 5x5. But look at what happens. If you try to do a 5x5 by cofactor expansion and you don't have a bunch of zeros in there, that's 119 additions, 205 multiplications for a total of 324 operations. If you do row reduction first, counting the row reduction, that's 40 additions and 44 multiplications. 84 operations. I go for 84. Now I know James is a hard worker. He probably wants to continue doing cofactory expansion. Knock yourself out, James, okay? Go for it. How about if you get up to a 10 by 10? Let's not go there, but what if you did more than 3.6 million additions, more than 6.2 million multiplications, for a total of something in getting close to 10 million operations. That's a 10 by 10. Row reduction, 669 operations. A little bit better than 9 million, okay? A whole lot better than 9 million. So row reduction is the way to go. I would say 4 by 4 or higher. So 2 by 2 you can do just looking at it. 3 by 3, just do one expansion. 4 by 4 and anything higher, row reduce. Unless you have a column with mostly zeros in it, and then you can just do your cofactory expansion. So what we're going to do on example 5, and what I'm going to do now is, oh wait, here's Ricky. I didn't see her there. We have a perfect full house today. Okay, way to go team. 4 out of 4. Ricky is in already. Good deal. Ricky, we're on in chapter 3 determinants, in section 3.2 determinants and elementary row operations, and we're getting ready to do example 5, the bottom of page 122. Now, I did ask this of the first two people after Jemanuel came in and Ricky. Oops, I'm sorry, Ricky wasn't connected yet. So I hope she is now. Ricky, did you hear anything of what I said earlier? Okay, we're in chapter 3 determinants, 3.2 determinants and elementary row operations. And we're getting ready to do example 5, bottom of page 122. Now, something I said earlier, and neither Jemanuel nor Ricky have heard this one. I just asked the question, have you all seen that chapter 2 test is out there on Blackboard messages? Aaliyah and James have both seen it. Have Jemanuel and Ricky? Okay, you don't have to have seen it yet. Okay, it's out there now. So chapter 2 test is out there. But just wanted y'all to know, because I knew y'all had a big 4th of July weekend coming up and you wanted some fireworks from your linear algebra, and so I wanted to be able to give you a few to play with. Okay, so that was supposed to be a joke. Okay, so let's go. Unless there's questions, any of the last two of you have any questions before we go to the share screen? So I'm going to do example 5 on the whiteboard. Okay, got to get my Wacom down here, and let me also, I need to do a little bit of moving around of things. Oops. Let me you can't see what I'm doing, but it is something that gets him. Okay, I'm having trouble here. Let me use my Wacom and do it. It seems to work a little better. Okay, and we'll move this far. You can't see my taskbars, but they get in my way so I can't see the whiteboard. Okay, and then I'll move all of you guys a little bit to the right so I can see more of the whiteboard. And finally, I'll move the whiteboard a little bit to the left and up so I can write on more of it. Okay, and let me also, I happen to hit with my pen, so clear that. All right, so here's example 5. Here's matrix A. Now this matrix A is only a 3 by 3. Minus 3, 5, 2. And I'm going to do it the easy way first. Minus 3, 5. And Ricky, you may not have been here to see this. This is how the easy way to do a determinant of a 3 by 3. Only works for 3 by 3s though. 2, -4, -1. Then repeat the first two columns again. 2 and -4. And then -3, 0, 6, and -3, 0. Now the reason I did that, I'm taking the determinant. That's not matrix A. I'm doing the determinant of matrix A, and that basically, now this is not good notation because you can't take the determinant of a rectangular matrix, but only for 3 by 3s this works. Okay, what we do is the product of your diagonal, down diagonal, and that's 12 times 6 is 72, right? The second down diagonal, 3 times 5 is 15. Notice I'm taking care of the signs as I go. And then the third diagonal, I like that one. What does that give you? 0. Okay. Now, I've done the down diagonals. Notice I used the positives of those. So I'm going to go up here and pick up my eraser. Okay. And I'm going to erase this bar here, but also going to erase these two construction. Oh yeah. This aggravates me so much about this package. This Wacom, if you hold it too long in one place, it changes what it's doing. Okay, if you do too fast, you do too much. Okay, now we're going to do our up diagonals. Okay, and up diagonals are always negative what they would have been. So this up diagonal would have been a 12 times 2 is 24, but because it's up diagonal, that becomes a minus 24. I said this was easy, but these are big numbers. This goes to 0, right? And this one is 10 times 6 is minus 60. Okay, well 72 minus 60 would be 12, and 15 and -24 would be a -9, so 12 minus 9 is 3. There's your determinant, 3. At least in my quick doing it is. Okay, now let's do it using row reduction. So I'm going to rewrite this. This time I will, well, I'm not going to do determinant yet. I'm just going to do row reduction. Minus 3, 5, that's an ugly 5. Okay. 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 5, 2. I don't need to expand it. 2, negative, it's supposed to be a 2, -4, -1. Don't need to expand that one. -3, 0, and 6. Now, remember folks, remember. Now, Ricky, you were here, maybe Jermaine, I don't remember for sure. If all you're doing is finding a determinant, and that's all we're doing here, okay, we have nothing to do with a system of equations or anything else, we're only finding a determinant. Finding a determinant, you can use what they call yuck, why am I going blank on the word? Row reduction or column reduction. I couldn't think of the word. Row reduction or column reduction. Okay? Now, the easiest thing in my mind, remember what we look for? the rows or columns with the most zeros in them. Well, we only have 1 0 here to work with. There it is. Now, how could we get another 0 in, say, that column or this row? Okay, well, guess what? This looks pretty easy. This is now a column reduction. Do 2 times column 1 and add it to column 3. Okay, that will give us, that will make that 6 become a 0, won't it? Now, I'm not about to say these are equal. They aren't equal. They're equivalent, column equivalent matrices. So keep the first column exactly as it is, minus 3, 2, minus 3. The second column stays the same. 5, negative 4, 0. And the third column, that's the one we're operating on, you're doing 2 times the first plus the third. So 2 times negative 3 is negative 6 plus 2, that becomes a minus 4. Now that makes it look like that got a little worse, okay? 2 times 2 is 4, minus 1 is 3. That got a little worse. But this one, 2 times negative 3 is 6 plus 6, that gave us a 0. Now let's take the determinant of that one. Why did we do this? We wanted a row with mostly zeros in it, and we got it. So we're going to use this position, the 3, 1 position, meaning we're going to wipe out row 3. Okay. Now the determinant of this thing here, which is the determinant of A, because all we've done is multiplying a row or a column by a multiple of another. So the determinant of A is going to be this negative 3. Now, you still have to do a cofactor expansion here. So the first question I ask myself, what's the sign of this position? Anyone give me the answer? Not of that number, of the position. What's the sign of that position? A positive. You start at the upper left, if I can get my pen to go there, okay, plus, minus, plus. So that's a plus position, meaning we use that negative 3 just like it is. Negative 3, and we're going to wipe out this column, if I could do it, and this row. Okay, that's why we wrote the negative 3 down. Now take the determinant of what's left. Well, the determinant of 2 by 2 is a piece of cake. That's, oh, yuck, that's ugly. Okay. Okay, let's get rid of that. All right. Okay, negative 3 times 15. And you normally would do a minus, but now it's minus a plus, so that would be a minus. Minus 16, and that would be negative 3 times negative 1 is equal to 3. Same answer we got before doing our expansion of a 3 by 3 and doing it. And frankly, I think this was even easier because you had one column reduction to get 2 zeros in that column. And then your determination of the matrix, all your numbers were smaller than anything we had in doing it the first way. So this actually turned out to be easier. A lot of times your 3 by 3s are going to be easier to do as is. The reason this was easier to do this way is you had 1 0 there already, so it made it really easy. And then in that same row you had a multiple of the other side, so it made it a very easy thing to do. So that's how they did it. You don't have to get it to a triangular matrix every time. If you can, it's really easy. But just doing maybe one row or column reduction, if that gets you an extra 0, go for it. However, you might want 2, or you might want to get it down to a triangular. But remember, your triangular matrices are always referring to the main diagonal. Don't ever do the other diagonal. That doesn't work. Okay. Well, actually, for determinant's sake, I think maybe it would, but they haven't showed us that, so let's not go there. Any questions on example 5? May have been some new material for some of you, but any questions? All right. So I'm going to clear. Oh, I'm using my finger on the Wacom, and that doesn't work. Okay. I'll clear those drawings and move to example 6. Oh my goodness. James, they came up with one of these. Here's A. A is a 5 by 5. 2, 0, 1, 3, negative 2. 2, 0, 1, 3, negative 2. Help me and make sure I'm not missing a sign or a number. The old gray cells aren't what they used to be. Okay. Negative 2, 1, 3, 2, negative 1. 1, 0, negative 1, 2, 3. 3, negative 1, 2, 4, negative 3. 1, 1, 3, 2, 0. There's our favorite matrix A. Did I get all the numbers and signs right? I think so. All right. Now, you tell me what would be the first thing you would look for in this problem. If you're trying to find the determinant, that's all. Not going to try to solve anything with it, just finding a determinant. What would be your approach? Okay, look for the most zeros in any row or any column. Who wins? Second column wins. It has 2 zeros in it. Nothing else has any more than 1. Row 5 has 1, and row 5 has 1, row 1 has 1, row 3 has 1, and column 5 has 1. But none others have 2. And the other bit of good news here is that your other non-zero entries here are all plus or minus 1, so they're going to add really easily to make zeros, right? So the only question is, which one do you use? Okay, now I don't think it really matters that much. So what I'm going to do, the same thing they do. I'm going to do the first one there. I'm going to use this one as my starting off point. Okay, so I'm going to use this one here to eliminate that one and that one, make those zeros. So basically that means we're doing determinants now, so I'm going to go on and put the determinant sign in here. No longer dealing with matrix. Matrix things would be okay because we're doing row reductions. That would still be true. But I'm going to start fiddling with the determinants. I'm going to do our row reduction. Okay, the first row is perfectly good. It has a 0 right where I want it, so let's just write it down. 2, 0, 1, 3, negative 2. You better have told me if, oh, don't do that. I didn't know. I thought I had to hold the key down for that to happen. I don't. Okay. All I have to do is drag. Okay. Now, the second row we're using, so we write that down just as it is. -2, 1, 3, 2, -1. All right. Third row already has a 0 where we want it, so we leave that alone. 1, 0. Again, linear algebra is a lot of repetition of a lot of stuff, so just have to slug your way through it. Now, row 4, we want that 1 to change. How do we make that happen? Yeah, row 2 plus row 4 becomes the new row 4. Okay, so do it. -2 plus 3, that gets easier. 1. 1 plus -1, that's what we wanted, a 0. 3 plus 2, oops, that got bigger, that's a 5. 2 plus 4, that got bigger, that's a 6. And -1, -3, that's a -4, that got larger magnitude as well. Too bad. All right, but we want that 1 to become a 0. How do we make that happen? Minus row 2 plus row 5 becomes the new row 5. I'm not going to write it. It's hard to write. Okay, so subtract or negate row 2 and add it to row 5. Okay, well, that's going to be a, come on, pen, get over there. Okay, positive 2 plus 1 is 3, so that actually got bigger. Okay, but -1 plus 1 is 0. That's exactly like we want. Oh, look at this. -3 plus 3, that goes to 0. Bonus here. Okay. -2 plus 2. Wait. Yeah. All right. Make sure I'm doing the right rows. -2 plus 2. Bingo. We got another 0 here. That was a bonus. But then on the other hand, a -1 plus 0, a minus of -1 be a +1 plus 0 is 1. So we lost a 0. But guess what? We picked up 2, gained 1. Picked up 2 zeros, lost 1. Hey, I'll go with that. All right. So now the next step is pretty easy. Okay. We're going to fiddle with this one. Okay, that's what we're going to be using. What is the sign of this position? Of that 1 right there. What's the sign of that? Positive, because plus minus plus, or plus minus plus. However you do it, that turns out being a plus. And by the way, everything on the main diagonal is a plus. Okay? So this is going to be the same as 1, which I'm not even going to write down, times, and what we'll do is wipe out that row and wipe out that column, and then do the determinant of what's left. And the determinant of what's left is 2, 1, 3, minus 2. 1, -1, 2, 3. You see what I'm doing? The numbers that I didn't wipe out, that's what I'm writing. 1, 5, 6, -4. And 3, 0, 0, 1. What would you do next? Anybody? James likes doing 4x4, so let's not pay attention to him. No, I'm just kidding. Okay. What would you do next? Look for the row or column with the most zeros. And what do you find? Fourth row. The second column and third column both have 1 0. Fourth row has 2. Now, can we eliminate a value and make that a 0? Anybody? You may not think of column operations, but that's exactly what we do. If we multiply -3 times column 4 and add it to column 1, that will make that become a 0. So let's do it to it. Okay? Oh, wait. Okay. I'll get more used to this in time. Okay. So, well, I was right. I was jumping ahead and going to do the next step. Okay. So we're messing with column 1. So the other columns are going to leave just like they were. If I can get my pen to come back, there it is. Okay. So second column is still 1, -1, 5, 0. Third column, 3, 2, 6, 0. Fourth column, -2, 3, 4, 1. So let's do the operation that we need to do on the first column that I've written down there. -3 times column 4, add it to column 1. So -3 times -2 is +6, and add it to 2, and you get an 8. Wow, that got bigger. -3 times 3 is -9, -1 is -10. Ew, that got bigger. Okay. -3 times 4 is -12. Wait, what? Look at what you let me do. That's a -4. Did I do anything else like that? Okay. Right up here? All right. -3 times 3 is -9. Oops. +1. You're right. I was looking at the other one. Okay. So that, thank you. Goodness gracious. There we go. It's a -8. Yeah. Okay. Okay. -8, which even though it's a big number, it's the same as one above, so that may come in handy later. But let's see. Long way to go before we get there. A -3 times a -4 is +12, +1 I think is 13. Am I right? And then -3 times 1 is -3 plus 3 is 0. That's the one we're most interested in. Okay, now what we have is this one is what we're going to use, because we're going to use that fourth row. What is the sign of that position? Anybody? It is a plus. If you do, everything on main diagonal is a plus, but you can do it this way: plus, minus, plus, minus, plus, minus, plus. Okay, yeah, it's a plus. So I'm not even going to write that down. So that will become, and these are determinants, so I can write this 1 times, and I'll wipe out this row and that column, and it'll leave me this determinant. 8, 1, 3, That's an ugly 8. I'm going to repeat the 8 and the 1, and then a minus 8, negative 1, 2, and repeat the minus 8 and a negative 1. You know what? Looking at this, it looked like a nice thing might have been then to add those top two rows together, because you wipe out two more zero. I think that'd be easier, don't you? I don't know if the book did it, but are we doing okay according to the book? I haven't looked at it. Let me wipe out this for a moment. Anytime you see a gift horse, don't look it in the mouth, okay? Let's just go on and do, okay? Let's just add what you want, row 1 to row 2 or row 2 to row 1, I don't care which. Okay, so let's leave row 1 alone. 8, 1, 3, and add those two rows together, and that gives you a 0, a 0, and a 5. Okay, and then just write down the next three. A 13, a 5, and a 6. Okay. Now the big question is, what's the sign of this position? That 5. Anybody? The sign of the position. No, it's negative, isn't it? Plus, minus, plus, minus. Or like I said, remember, everything on the main diagonal is plus, and that's just one remove from there. Or, the way the book does it, this is the 2, 3 position. 2 plus 3 is 5. That's odd, so it's going to be minus. So this is going to be a minus 5, and then I'll wipe out that row and that column and do the determinant of what's left. Well, that would be a 40 minus 13, isn't it? This is an awfully big number. That looks like to me to be a 7, no, negative 5 times, have I made a mistake here? That would be 17? No. 27. No. Yeah, 27, I think. The old gray cells aren't working too well this morning. I'm getting suspicious. Oh, maybe not. Maybe not. Well, come on. There we go. I think that's a 27, isn't it? And negative 5 times 27, that would be a 35 here. 135 with a minus sign. Okay? Negative 135 is your determinant. You know what? I'm really glad we didn't expand that 3 by 3. That would have given us some enormous numbers. These are big enough, but these have been kept to a minimum. No way around getting big numbers if your answer is negative 135, but they won't be nearly as big as what we did before. So anytime you see a pattern like that, like a bunch of numbers that do the same operation to them, and you're going to be able to get some zeros, get all the zeros you can. Okay? Does everybody see how? Now, did they do it the same way? I do believe they did. Not quite. Somewhere they had swapped some rows, didn't they? Oh, no. What they did what James said. They added the second row to the top row and got that to become a 0. Okay, so yeah. Works out the same, folks. As long as all your steps are correct, you should get the correct answer. And we got negative 135. doing it slightly differently from what they did, but not much. And guess what, team? That finishes 3.2. Homework exercises here include any of the odds 1 through 19, either 21 or 23. They should both, all the odd answers should be in the back of the book, but you can also go to calcchat.com for worked out solutions to those odd exercises. So that's why I assign them. Either 21 or 23, any of the odds 25 through 35, 37 is a true false. It has 3 pieces, so try to do each one of those. The answer should be at CalcChat. Do either 39 or 41, or both if you choose. They should be at CalcChat. 43 is a proof. It should be at CalcChat. 45 is just finding a determinant. That should be at CalcChat. 47 is a guided proof. It should be at CalcChat. And that finishes 3.2. Any questions on 3.2? Now I know for some of you that may have been the first time you saw it, and maybe first time you saw chapter 3. Is any of this mystery meat to you, or are you catching it okay? Any questions? All right, let's move on to 3.3 then. All right, now we're still dealing with determinants. This time it's properties of determinants. So let's look at what happens to matrix products and scalar multiples and see how this affects determinants. Okay, so the first one here, oops, I keep fingering my pad here and it doesn't work with the finger, it needs the pen. So I'm going to clear all the drawings, and they give us 2 matrices here. Let me write them down. Matrix A is 1, -2, 2, 0, 3, 2, and 1, 0, 1. There's matrix A. Here's matrix B. 2, 0, 1, 0, -1, -2, and 3, 1, -2. Okay. Now, they ask us to do several things. The first thing they said is to find the determinant of A. Okay, now here's how I'm going to do it. It may not be the easiest way, but I think it will be pretty straightforward. I'm going to expand, because that's a 3 by 3, do a 1, -2, 2, 1, -2. Just expanding the first 2 columns. Now I'm going to put the matrix bar, the determinant bars there, even though I know technically we're doing a determinant, but not of a 3 by 5. We're just writing it in that form. 0, 3, 2, 0, 3. Okay, and 1, 0, 1, 1, 0. I hope I got it right. I know that's not lined up too well. All right, so the determinant of A would then be, one thing that's happening, I was thinking it was all my writing, but the Wacom is slanting, and that's why I'm getting a sort of a slant in there. Let's do down here, that's going to be 3. Multiply that first diagonal, 3. Multiply the second diagonal. That's a -4. Multiply the third diagonal. I can do that one. It's a 0. Okay? Now, I'm going to come up here, get my eraser, and erase these construction lines here just because they get in the way. Okay. Now, let's do our up diagonals. Remember, we always subtract the up diagonals. That's a -6, 0, 0. I knew with all those zeros in there, this wouldn't be too hard. So that's -10 plus 3. My guess is that's a -7. Okay. And the book got it right. Good for them. They didn't do any of the work. They just wrote down the answer. Shame on them. Okay. So let's do the determinant of B. And that will be something like this. 2, 0, 1, 2, 0. 0, -1, -2, 0, -1. 3, 1, -2, 3, 1. Understand that's not really a determinant, but we're using that to do. So do the first down diagonal, and that's going to be a +4. Second down diagonal, one of my favorites of all time, is a 0, and the third down diagonal is a 0. Okay? So let's go up and get our eraser and wipe out those 3 construction lines, and let's do the up diagonals. And it's minus a 3, minus a -3, which is another +3, and minus a -4, which is +4, and then the last one I can do is a 0. So what does this give you? Looks like 11 to me, doesn't it?